you guys may already know this. And if it's repeated, no big deal. But again, this is like kind of 10,000 level view, like what's happening, how does the internet work? When you put a URL in your browser, what's the chain of events that's happening there? Okay, so we've got a person, a user, and they have a laptop, it's running a browser, and they have some kind of a URL. Let's call it google.com just as an example. And so they hit enter. And then typically that request goes out on the internet. There are a couple different things that are happening here. So the internet is made up of layers of protocols. I think there used to be 7 protocol, like a 7-layer stack. Now they've simplified it. It's a 5-layer stack. They merged a couple layers, but there's a couple different stacks. Typically what we're going to be using is something called TCP IP, which is the stacks. There are other protocol stacks like UDP, but I don't really think that needs to concern us today. What ends up happening at the highest level, so the highest level is the application. This is the browser that you're using. That's the application layer. And then you go down through all the layers. Now, I didn't review the 5 layers before I came in. So I'm gonna, like, Reader's Digest, big picture what the layers are here for what I did teach this once upon a time for an entire semester. So I remember enough to be dangerous, but I didn't actually like get all the names like at the tip of my fingertips. So at the top level though, what's going to happen underneath the application layer, our application is going to make what's called a GET request. That's to retrieve information. There's also, so I'm going to just put this in a different color. There's also the possibility of a post request, and post requests have hidden data. And again, any of this I can dive more into. I'm trying to do top level view right now. So with a GET request can have data too. Have you ever seen something like an ampersand x equals 1 and y equals 2 like on a URL? Like you'd say like google.com/ x equals this and y equals that, something like that. These are called name value pairs. And so that's how a GET request can communicate data, can transmit information. It can also, the URL itself can also communicate information, and that's what's called a REST approach, where you would have google.com/ x/2/y/2. They're just different ways of communicating information in a GET request. So you can either do it the REST way or the name value pair way. When you have a post request, by contrast, I'm going to try and get this. There we go. When you have a post request, the data is going to be hidden. You're not going to see it on the URL. Okay, and so cookie data is often, like anything hidden, passwords, things like that, anything you want to keep private, that it's not going to be apparent from the URL. That's going to come on a post request. So there's GET and post requests. And so then, we travel through the layers on our computer. Eventually, the information that we're requesting, google.com, it gets broken up into packets, which then get converted into bits, 0s and 1s, and get transmitted to the next step in the chain. We don't always know what the next step in the chain is. If you think about it, it's kind of like, so the idea here is one of routing. Where does the data go next from here? Like how does our computer know where to get google.com from? Like the internet's this big cloud, this big amorphous blob. It's totally distributed. It's totally asynchronous. So what happens is that every computer that's connected to the internet has what's called a DNS, or a domain name server. And basically this is an address lookup, specifically an IP address lookup. So the idea is that google.com is tied to an actual IP. And IP addresses are things, you've seen them before, like a local one is 127.0.0.1. That's an example IP address. It always stands for the current machine or local host. Trying to relate as many buzzwords that you might have seen as possible, kind of put them together, big picture. So, your computer might not know right out of the box where to find google.com. It's kind of like, I know that my students have a teacher. They have a teacher in front of the classroom. I don't know where the teacher lives. I have to find out. I mean, I know I could go to that place if I knew the address, but I need to find the address. The school may or may not give me the address. Good news is that on the internet, the domain name server has the address. And if the domain name server doesn't, it knows how to find it. It'll go to a different registrar to get updates. And so periodically the domain name servers, they get updated. So that's why sometimes things can kind of go down and be redirected. With a production level site as big as google.com, you're actually going to find that the server, the IP address for the server that's going to deliver google.com is going to be different. Like we're probably all getting google.com from a different physical server because Google, as a huge, huge multinational corporation, like it's just, the scale is amazing. They're going to have server farms, not just one server, but a whole farm of servers all over the world to serve up our google.com web pages. But a smaller website like we might create to start out for our clients, that's going to be hosted probably at one location. And so that's why you're going to see a little bit more lag because there is latency on the internet. Like physical distance does play a part. It's physical distance and also the number of hops. This is what the cloud is hiding, is that nobody really knows exactly how to get to that server. It just, well, all we know is where's the next hop. It's a little bit like the Postal Service. And now, Arthur, I don't know in the UK if it's similar, but in the US, the Postal Service is a little bit distributed in that you kind of send the package to the next closest place. And then from there, it goes somewhere else, and eventually it gets to your post office. And you may not always have the full trajectory of every stop along the way. And that's kind of how the internet is. You just know that the packet of information that you're sharing and you're communicating goes to the next place. It goes to the next place in the chain. And so that server might not know where this packet of information came from or this package, but it's going to pass it on and get it closer to its destination. So sometimes you might request google.com and it goes to 3 or 4 servers. Sometimes it might go to 8. And you can kind of look for this kind of information if you're interested in something called traceroute. It's other things you can do are ping. These are just Unix commands that you can also run on the internet or you can run natively on your own machine where you can like ping an actual IP address, ping a domain, traceroute. You can see all the places that are there. The other tool,
Sorry, I don't mean to interrupt. Could you demonstrate that at some point, like pinging an IP address so that you could see where it goes around? Because it seems a little bit out of my understanding.
Awesome, let's do it. Yeah. That's a great question. The only other, and I'm just gonna, because I'm gonna have to.
Sure. Sorry, I didn't mean to interrupt.
No worries. Not at all. This is perfect. Thank you so much for asking. So the other, if you're really into this stuff, and again, to build web applications, you don't. What I'm trying to do is give you like high level perspective. If you start seeing like words of bugs or errors and you're like, what is that? I'm trying to give you like that big picture of how these pieces all fit together so that you're armed with at least terms you can Google for to get to that answer or understand what Google is telling you, right? Like that's our goal. And so the other thing that I don't remember if I mentioned precisely was as we're going through these layers, right? We start off with the application layer, we get a URL, and then we go into the TCP/IP stuff, and we start breaking this up into packets. We form it into a request like getgoogle.com. And then it gets broken up in the lower layers in very well-defined what's called packets. So let's say your URL is really long. Well, that might actually come across as like 2 requests or 2 packets, right? Like if you, depending on how much data you have, or especially when we're getting data back from the web server itself. Right, so there's going to be like a limit, a very well-defined size on that packet, and all of this is happening behind the scenes, like we don't even know it. And then eventually, those packets get converted into binary and transmitted either over air or on the wire. And so then it gets picked up by we usually request the domain name server tells us, google.com, where am I going? The client computer gets that information, it gets the IP, and then it forwards the information it has, like getgoogle.com, to the server. It's forwarding it, though, to the closest router it's connected to, which is then going to choose, okay, which network that I'm connected to does this go to next to get us to that server? And that happens repeatedly, again and again and again. You can almost envision it like, it's like bouncing around like a ping pong ball. Like It gets to a server. The server opens the package, looks at it, unpacks it, has to figure out where it's going because it, at some level, all the data is zeros and ones, right? So it has to like come up a couple layers, figure out where it's trying to get to. And then most routers are connected to multiple networks, maybe 5, maybe 10. And so then it figures out, okay, which physical link network can I send this to that'll get it closer to this server that we're looking for? And then it forwards it there. Amazingly, all this is happening like that, right? Like there's all these steps happening. Like you just typed in google.com and like all this stuff is going on behind the scenes. This is why latency and like speed can be so important on these web browsers, on these web applications, because so many steps are actually happening behind the scenes. So that data packet is bouncing around the internet, and eventually it makes it on the other side to a web server. Actually, I'm going to change what that looks like. Okay, so we've got our web server. So eventually our data, somehow our packet bounced around and got to the web server. Now it's possible that the data came in out of order, like the packets got shuffled in transit. And so the web server is going to hang out there waiting. The packets all have a number, like a sequence number. So it knows, okay, oh, packet 2 came first. Okay, I'm going to wait for packet 1. I know it's coming. Behind the scenes, I'm not going into detail about it. This is how, why things are called like TCP IP, is because there's a very well-defined protocol for how the user and the server are going to communicate that they received packets. There's, again, I'm like, these are like just big picture words. They're going to be sending things like SYN and ACKs. Again, at the application level, you shouldn't have to worry about these. I'm just sharing it so you kind of understand what's happening. But like they're like the client's going to send the data and it's going to be like, hey, did you receive it? And the server's going to be like, acknowledge, yes, ACK, I did get it. I ACK it. And so this happens for every packet. There's like this handshake. We send it and do we receive it or not? And so it's possible because every packet is taking a different path through the internet potentially. The order, like things get dropped, like a server gets flooded, it goes offline, like a router in the middle of the internet, right? Like there's a power outage in New Jersey, and so Arthur loses the ability to get joyofcoding.com or whatever it is, right? Like there's going to be something that can happen. So packages are lost, and so the server and the client acknowledge each other. So that's happening below the application level. Eventually, all the packets arrive at the server, and the server puts them in order, unpacks them, figures out what the request was, and then figures out what it needs to do. Usually a server is listening at ports. So for example, port 80 is the port that servers listen to for what's called the HTTP protocol, Hypertext Transfer Protocol. That's the level of most web applications, HTML, CSS, stuff like that. Most of you have heard of that. What we do for when we're building our own apps is we often take over the port, 8080. Although you could really do it for any port, it's common for dev is to use 8080, could be 8088, whatever you wanted. Every service on the internet has its own well-defined port. MySQL, I don't know, SSH is 25, for example. MySQL has a port. I don't remember off the top of my head, but every basic service has a port. And so the server is open and listening for packets and for requests coming in at those ports. So the server's listening on the ports, it gets the packets, it unpacks it, it figures out, okay, this client, this computer is requesting google.com's homepage. Awesome. So it grabs the HTML for that. It knows where it's living in its server. And then it packs it up through all the layers, splits it up into packages, sends it back. And this whole process begins again, only in reverse. And if there's information on the web page that requires like a database, right, the server is potentially interacting with the database. Usually that is hosted inside like the server's network so that it's not going outside places. But there's nothing that says the database has to be physically located in the same network as the server. So then that process would have layers as well. But usually we're living at the application layer. So we just like normally how we view this process is I'll just do it over here. Usually we've got like a person makes a request of the internet, and then there's a server somewhere, and then there might be a database server. Okay, this is usually how we think about the internet. But what we're talking about today is what's actually happening. All the layers behind the scenes of what's going on to help us better understand. Mostly it's to understand the error messages we're seeing and the directions. Like if we Googled something, oh, I'm seeing this error, how can I improve that? It also gives us ideas for how do we improve the efficiency of our applications? Because in terms of efficiency, there's really two main ways that we can kind of work on that. Let me see if I can find a bright enough color. There's going to be client side efficiencies that are possible, but there also are going to be server side efficiencies. And so we just want to make sure that we understand where the slowness and the lack of efficiency is coming from. Is it dryness in our front end code? Is it dryness in our back end code? Is it the internet? This is why so much code is happening on the client side now, is because we can't control the internet, right? You cannot control, like this big piece in the middle, no control. That is not within our circle of control. We can control what's happening on the client side and the server side. That's it. Everything else, you throw it up with a hope and a prayer. So usually it works. This is why we have error handling, and other things like that. But we really don't know what's going to happen on the internet with all these different steps. So we can improve efficiency on the server side and the client side. And this is why people have been moving a lot of code to the client side, because they found that people tend to be patient when a website first loads, and then they want it responsive. So we have to put that logic in the client side so that we only have to send the web page content once, and then it's super fast and responsive. So that's why client side code is because front end. So this is also front end, sorry. So the front end versus back end. I just want to make sure everybody is clear what these things are. Because you might see them use these words in different places depending on what you're reading, like client side versus server side, front end versus back end. Because front end, back end are really application level. Yeah, Arthur.
I just wanted to ask, how does WebAssembly work in this sort of environment?
So Rust is a language like any other. Yeah. It sounds like people like to use it for systems level things, so it could be back end. However, you can use it on the front end with WebAssembly. So it sounds to me like the role of this is that WebAssembly enables you to use back-end style technologies and do systems levels tasks on the front end, potentially. So that, at least that's my read on what I saw. But WebAssembly is a little bit different from actual assembly. Like that's a lower level thing.
I'm a little bit confused as to what WebAssembly is doing on the front end though.
Yeah, it says WebAssembly has made it possible to build front-end apps in Rust.
Okay.
And so Rust works with JavaScript, except it's got static typing, which JavaScript doesn't. So there's more type checking. This is what
you have to use TypeScript with it.
No. Right. Yeah, exactly. So I think WebAssembly is just allowing you to use other languages and other capabilities. Based on what I've seen, and I just Googled what's WebAssembly. I Googled WebAssembly, and it's a virtual machine. So basically, you know how Java works with a virtual machine, and so it's not compiled into binary like C and C++. It's compiled to the virtual JVM, the Java virtual machine. It sounds like WebAssembly is the same thing, but for web stacks.
So it has like its own JDK that it works off of, for example.
Kind of, yeah. Like it has its own it's a virtual machine. I don't know if it has a JDK or not. It probably does. But it's going to ship with some kind of a virtual machine so that it's platform independent. It's basically, it sounds like a little bit like Java 2.0. It's an upgraded like Java. That's why Java became the first internet programming language, is because it had applets because of the JVM. Like that's what made it possible. So it sounds like WebAssembly is like that next evolution of it.
can you give me a simplistic role of what exactly the server does? Other than, I mean, I hear what you're saying. It goes through the mess that is the internet, retrieves data from the server, and then comes back. But I mean, how can how can someone sitting over here manipulate a server over there? Because I know I can do that with the DOM as a front end developer. I can understand, okay, I do this and it does this. How does someone sitting down on a computer over here manipulate data from a server? Is it just sending fetch requests and getting fetch and get? Is it just doing that?
Basically it's getting post requests and it's transferring the data back and forth. And so this is where that dividing line, like I know you can really focus on the front end, which is totally fine, but this is where that back end piece comes in. Like, hold on, I have to wake this up again. All right, so we've got our basic idea down here. On the server, you have what are called routes. If you're following a REST, which is traditional, if you follow a REST version of it. So like you might have google.com/ads. This is going to retrieve a different page on the server than just straight google.com. And so it's not like someone on the internet is manipulating the server and the data on the server. It's that the server is making, it's like making the API available to the client. So like the server allows the client in very controlled ways to interact with the information on the server. And so, but the server defines, right? The server defines it in a couple ways. The ports it allows to be open and allowing the client to connect to it. And then once it connects to the port, there's the actual API itself, these routes, you know, what is allowed. So for example, like, let's say you go to a college webpage, college.edu. Maybe there's like a professor and they have a web page. You might be allowed to access ~prof, but only if they've defined an index.html or an index.javascript or an index.php. You may not be able to access that otherwise. And those are server level settings. I don't know if I answered your question quite yet.
No, it does make a bit more sense. So basically they can manipulate the behavior of the server, but not the content of the server.
Right. Only the server can change the data on the server or the database, but the user can request that the server create those things. It's kind of like how in Java, because I know you looked at Java, you know, we can't necessarily change all the fields because they've been made private.
Yes. Until you make them public.
Right. Or you provide set and get methods to access that information, and you control it a little bit. So you could put error checking in. You could put blocks in to kind of protect that access if you want. All right, live testing. I didn't test this in advance. So things go wrong. We get to see a real-time error troubleshooting. It's an opportunity. All right. So I'm just going to ping google.com. Let's see what happens. Cool. Okay, I'm going to do Control-C. That's going to exit out of the command. So 5 packets were transmitted, 5 packets were received. There was no loss. Okay, and it didn't take very long. And so that's the IP address, 142.250.80.110, that my computer uses for Google. And if you have access to a Unix command line, you can do that same command and see what IP address you get, and it'll be different. I can guarantee you it'll be different because Google is huge. But for example, I could also ping like my university website, which is not going to necessarily be as prolific.
Before you go on, right above where you're typing right now, where it says Drew EDU, right above that it says STD DEF, that's standard dev. So look, or you're letting the pings run for the. All right, so you canceled out again. If she lets that run, it's going to keep pinging like a radar. Like a radar on a sub, just like every 1 second, it's sending out a signal. It's either going to get a response or it's not.
Yep. Yeah, and there's like TTL time to something. I don't remember. I have to Google it. But you can see like these take so much longer. So this university is in my town. Physically, it is very close, but it is not at the Google level of production. Look at the difference in milliseconds. 6:35, right? really big. Or I could ping, let's see, UCLA.
When she talked about those packets, like you're sending packets over the post office, that's that first bit where it says 64 bits or 64 bytes.
Yeah.
Every one of those packets is exactly 64 bytes. No bigger, no smaller. It's sending out chunks of 64, just because that's what's the information that's in that ping.
And then we can see, like, when the server is physically farther away, like UCLA.edu is across the country for me, it's taking 80 milliseconds.
Yeah.
And we could ping for fun Amazon. Like, so it's fun to kind of compare like way big sites like that are scaled and production level versus like small mom and pop style sites. Like small mom and pop is a university. I know for internet it is. Okay. So Amazon's not as fast as Google, but it's pretty good.
Yeah. Yeah.
Cool. So does that help explain what ping does? And I want to
that helps explain. Well, it gives you a visual for what it's doing, and that's pretty much what I'd like to do. I mean, like for example, with JavaScript, you can see how fast it takes to compile to pass your code, and you said you could do that with a website. I thought it was quite cool.
And this is how you can tell if you need to upgrade. Like, let's say you're hosting, like, in the beginning, you're developing locally. And eventually you're going to want to deploy your application on the internet so someone else besides you can see it, like your client. And so then you might use a free web hosting service like Heroku. How do you know that you need to upgrade it? Like if you don't hit any of their data limits, when do you know it's time to upgrade? Well, if the lag is too high for your client needs or for your needs. So you can do the ping, you can do some of these things to kind of see, okay, maybe I need to upgrade it now. So let's do a trace route. Yeah, Google might not be the best trace route because it might not be very many hops. I think it got there in like one hop. There we go. Oh no, Verizon. Verizon's my service provider. So what traceroute is doing is it's sitting on top of ping and it's tracing. You know how we said you can't tell what path the packet is taking? Traceroute allows you to figure out that path. And you just let it go as far as you want. I think when there's 3 stars, it's like it's dropping that. Like that packet's not coming through.
Are those geo coordinates? Like you can check where it's going to? Or are those just random numbers? I don't know.
These are IP addresses. So these are server addresses.
Cool.
Yep. So we can, and there's only so many top level IP addresses. What happens is like, for example, if you were on campus at my university, it would look like all of your packets are being sent from the same IP address. Because there's only so many IP addresses in the world, like you can't have that many. So within a connection to the internet, there might be, thousands of computers all masquerading as this one IP address. But inside, there's like more. Any connection to the internet could potentially connect to like around 64,000 other devices inside the network. Because they use the ports to figure out who's who. But so what's happening here is like, okay, so this is me. Here's my IP address. 192.168.1.1 is a local network IP. So just like 127.0.0.1 is your computer. 192.168.1.1.1 is like is a typical network, a home network. And then it ends up at Verizon. And so this is the IP address. This is the name of the server. And then it ends up at alter.net. I don't know where that is. A bunch of alter.nets. And then here's some other redirecting things that are happening. These could even be in Google. I don't even know. I don't know what 1e100.net is. Although that isn't that a Google? Isn't e to the 100 a Google? Like it's a mathematical term. Googol. So that's probably Google right there. But I don't really, these are probably Google IP addresses. So within their server farm, it gets bounced around and then somebody serves it back. Because at the end of the day, there's a server returning it. Whether you've got one server or thousands of servers, there's a server somewhere. So here's Verizon. I'm just, showing a comparison of traceroute. If you're really into it, Arthur, there's something called Wireshark that lets you pull apart all the packets. I think that's overkill for your needs.
I think it is currently overkill, unless I want to go into WebAssembly, but I'm not. I'm quite happy playing with JavaScript.
Having some of these tools can help you troubleshoot and debug and understand the error messages. So that's the purpose of it. Again, we're not spending weeks on this. Like I have taught these tools as part of an entire 16-week class, right? We're doing it in like 45 minutes, you know, like, relative, right? Like this much, a little sip. We're doing a little sip of networks, low level network stuff to make sure those foundations. So you have something to go off of when you see these words. I'm going to just CD into my downloads. We can use a tool, a Unix command line tool called wget will help us access like any web page on the internet and download it. The way this can be helpful is you can also use this to test your website. You could just do it through the browser. Or if you wanted to have automated testing, this gives you a way to do that, because you could actually give it a whole sequence of URLs with get data and post request data, and you can get cookies set up. Like it has a lot of powerful features. I believe that most of the modern web development tools supersede this, but it's there. I like wget because it also allows me to download every web page on a website. It's a web spidering and crawling tool. So like, let's say there's a website that you really like and you'd like to have a copy of it in case it, disappears. You can tell it, do you want it to spider across links on other domains or just within the current domain? Or like, there's all sorts of cool bells and whistles you can find on that man page.